This is going to be an open forum. I want the team members here to ask questions as we go, contribute. Everyone's team experience is appreciated. Spray booths as a topic is kind of a difficult thing to sell because it's always a little bit different on each and every case. Every city, every state, every application has oddities and specific things that have to be addressed. So it's part of the challenge, but also what makes it a specialty item to sell and not just a commodity is expertise counts. So I'm going to hit the present button. Everybody can see this?
Yep.
There was our theme music. So why do I need a spray booth or mix room in the first place? Does anybody have a guess on this?
Safety and compliance.
Mm-hmm. Well, there's actually a reason, and it's legal. So every building that you have as a commercial building has a zone requirement, right? So some buildings are zoned for storage, like warehousing. So that would be a zone S building. Like if you ever looked at legal plans for building, you'd have zone M for manufacturing, zone S for warehousing. And then they would actually also have what's called Class H for hazardous operations. So if you were a fireworks factory, for instance, your building would be zoned as Class H, hazardous. And they have H1 and H2. They have S1, S2, M1, M2, depending on how much manufacturing, how much warehousing, what kind of things you're putting in that building. So the purpose of a spray booth is to get you the legal requirement met. And what the spray booth actually does is instead of the entire building becoming a hazardous building or a hazardous room within the building, the spray booth itself takes on that legal classification and is the hazardous zone. We're basically saying everything in this booth is contained and rated and meets the classification of a spray booth, and therefore I legally don't have to classify my entire building or my entire room within a building as a hazardous location. Why would we want to not classify an entire room or building as a hazardous location? Does anybody have a thought on that?
I have a question before you go any further, Ty. Does it
Sure.
matter whether it's an open spray booth or a closed spray booth for it to classify that?
It does not.
Okay. Thank you.
Yeah, no problem.
So that you can have people in the area.
Yep, that's part of it.
Also fire hazards.
Well, how about costs? If you were to make an entire building a hazardous rated building, the entire building would have to be Class 1 Div 1 or Class 1 Div 2 explosion proof wired. You couldn't have anything made out of a combustible material. The walls would have to be concrete, right? So the costs alone of having something rated for that would be exponential. So that's a reason why a spray booth becomes necessary legally. But I went back too far, so apologize for repeating this. All right. Typically, when we put in a spray booth, what permits are required? Does anybody have guesses?
County or city?
Well, you're going to, depending on the location of the customer, you're going to have, multiple jurisdictions. It could be a county, it could be a city, it could be a state, could be a federal government,
Fire marshal.
Yeah. So typically your permits are going to be mechanical because we're penetrating through the building roof typically or a sidewall to exhaust. So therefore your mechanical permit. We're also anchoring to the concrete, which would also be in the permitting of that. Obviously you're going to have electrical. If we have heated air makeup, we're potentially going to have gas, or if we have an oven. Every spray booth is going to need fire suppression. So whether your building has a water fire suppression system existing, or if you need to put a dry chemical suppression system on. If you live in a populated area, odds are you're going to have an air quality district, and they're going to require you to get a permit because we're going to be exhausting out into the environment the paint-laden volatile air. And a lot of people miss, but if you have a fire alarm in your building, you need to also get a fire alarm permit so that if the spray booth catches fire and triggers the alarm, it would, number one, turn off the booth. Number two, it would automatically trigger the alarm and call for help. Does anybody know what book is called the Spray Booth Bible?
All right, really quick, on the alarm system for the fire, does that trigger off the fire system within the spray booth?
So if a fire triggered a fire suppression system, it should by code trigger an alarm that calls the fire department. If your building has an alarm system, they need to be tied in together. Two separate things. There's fire suppression and there's fire alarm.
Okay, thank you.
They're typically two different trades, by the way.
I'm going to guess NFPA.
Yes. Moving into what is the Spray Booth Bible? The NFPA 33 is probably the code that is the most comprehensive to do with spray booths, right? NFPA stands for National Fire Protection Association. They wrote all of the codes having to do with, obviously, fire protection. Additionally, codes that will come into play will be any kind of a local statute or state statute, in addition to the national. Local OSHA and national OSHA codes come into play. In fact, OSHA requires you to have a spray booth if you have any airborne particulate. International Building Code, the National Electric Codes come into play, the NFPA 33. And another one that comes into play often more for heating and curing with ovens is the NFPA 86. And then, of course, your AQMD, your Air Quality Management District, is also going to have their own codes and requirements as far as exhausting and tracking your VOCs and that kind of thing. Any questions on codes?
Mm-mm.
All right, so the first piece of equipment we're going to review is a paint mix room. Does anybody have any thoughts or questions on a paint mix room?
Usually it's referred to as a mixing lab.
Yep.
Yep.
Mm-hmm. So a reason you would want a paint mix room, obviously there is the color corrected lights, so you could have a place to work and see colors correctly. You could store flammables in there, which would avoid you from buying multiples of those like yellow or red safety flammable storage cabinets, which are pretty expensive. I actually had to buy one recently and it was like $2,000 and it only holds, 40 gallons or something. So a mix room can store a lot more material than that, give you a place to work. The maximum size of a paint mix room is 150 square feet by code. That's in the NFPA 33. And you may store up to 2 gallons per square foot. So that means I can store up to 300 gallons in a 10 by 15 paint mix room. Common sizes are 8 by 12 and 10 by 15. You can, however, make a paint mix room any dimensions that you want, as long as you don't exceed 150 square feet. So you can get quite creative with the dimensions. The room needs to be bolted and sealed to the ground. We typically use an epoxy caulking so that things can't run underneath of the walls, because it does have some containment to it. You will have to put in, if you're going to put drums or something, you have to put in a ramp typically over that door, because there is normally a 4-inch curb all the way around the room. So something to consider if you're selling these. And standardly, you get a 36-inch door. However, we have done ones where customers want to bring in and forklift totes in, or larger items. So you can customize the door opening to any size you need. I've even had them where we had a roll-up garage door on them before as well. There's a required airflow in the booth, and it depends on the use and the manufacturer, but it's certainly done in air changes per minute. So you normally see on the low end of the spectrum about 4 air changes in the entire room per minute. On the higher end, depending on the manufacturer, around 8.
So does it have constant ventilation 24/7?
Yes, a paint mix room actually should run 24/7.
Okay.
If you notice the paint mix room that we're picturing here, there's a vent in that door. That's the air inlet. There's an actual filter normally in that inlet. And then there's just a simple small 12-inch exhaust fan on the top left corner, and it's bringing the air out. If you look in this lower photo in between the shelves, that is the exhaust fan plenum. So it's pulling the air down low by the concrete, because the solvent-laden air is heavier than normal air. So you want to pull off the bottom of a paint mix room and exhaust it out.
Mm-hmm. You know, Ty, both shops that I visited, they didn't have a mix room. It was done along a wall on shelving.
Mm-hmm.
Again, is that just local code allowing that?
Well, was the material flammable? That
Okay.
would be what would drive it. If it was water-based material, it doesn't necessarily have to be in a paint mix room. If it's flammable, it certainly should be.
Okay.
Ty, what is the temperature in those mixing rooms? Where does it have to be at?
So a typical paint mix room is just drawing ambient shop air. We have done them specialty in certain environments where we've put in heating and air conditioning. We normally just mount a unit on the top and put that in. That's an optional adder that could be done. We've also done it where people want to store powder in a paint mix room, which is certainly a good use for it. And we put air conditioning in there to keep it cold and dry.
Thank you.
Mm-hmm. Okay, so what happens if you want to store more than 300 gallons? That would be a use case for a paint storage kitchen. So I wanted to highlight this because paint mix rooms and paint storage kitchens are very, very different things, and people sometimes use the terms interchangeably, and that can be dangerous, especially on a permit application or a plan going to a city reviewer. A paint storage kitchen is going to allow you to store a whole lot more paint depending on the size. I mean, these can be 40, 50, 60-foot long kitchens. They normally have to have a large sump in the floor with grating. They have large containment zones. They're equipped normally with explosion relief venting. So if there were a fire inside, it would vent out. Can be set both indoors or outdoors. There's some photos. Normally in a paint storage kitchen, will also mount a lot more pumps and things. You can mount pumps in a paint mix room as well, but here's some local examples of these are actual TFS install photos. where we've done that. You can see on the left photo there how much larger a paint storage kitchen is versus a paint mix room. To give you some concept, a paint mix room is probably $12,000 to $15,000. A paint storage kitchen is probably in the $40,000 to $60,000 range, depending upon requirements. So you can certainly normally buy multiple paint mix rooms if you're trying to store 300, 600, 900 gallons. But if you have large requirements, you're putting totes, many thousands of gallons, a paint kitchen for certain size manufacturers becomes quite the necessity. Did anyone have any specific questions on the difference between a paint storage kitchen and a paint mix room?
No.
Okay. So now we're going to get into spray booths, specifically types of spray booths. So the first one up is a spray plenum. Everyone's probably seen that. It's just simply a wall of filters with a short plenum and usually an exhaust fan on top. But guess what? This is not a spray booth. I put it under the section of spray booths because it's typically the first piece of equipment that we sort of recognize in the realm of spray booths. But in a legal definition, this does not equate to a spray booth in any way. If you put this in a room, the entire room would need to be rated as hazardous, like we discussed on the first slide. And the room would have to be considered a spray room. That would mean the room needs explosion-proof lighting, explosion-proof wiring, no open outlets. The entire room would need to be made of non-combustible materials, no wood, that kind of thing. No wood floors. So this is an inexpensive way that people will come in sometimes and move air, but does not meet the legal requirements of a spray booth in any way. Now, where might a good use for this be?
Well, in
Like
Texas,
a sanding department or something?
Yeah, people can certainly put dust filters in and use them as a sanding wall because a dust booth doesn't exhaust outside.
I've seen several guys being told that they can use them for waterborne.
Not the case at all. There's no difference between solvent and waterborne in the eyes of the code books or the law. The reason simply is because tomorrow you could walk in with a 5-gallon bucket of solvent and start spraying, and they would have no idea, and it would be unsafe.
Yeah.
Also, there are solvents in all of the water-based products to some degree.
Right.
So
You had a sectioned off room in a building that you're using that is your paint room. Would that be a spot for that?
yes, so I actually have a good example here in the Portland, Oregon area. There is a couple of hangars that Boeing actually flies planes into for repainting for commercial airlines. The entire hangar is actually rated as a spray room, and because it's such an immense amount of air they have to move, they have multiple spray plenums all around the room, and it actually makes the best use because you're able to get air in multiple locations rather than just trying to do one giant huge booth. And now they went to the whole trouble of making the entire room class 1 div 1 non-combustible materials and all of that, so it was built specifically for it. But that's a good use. You're still required to have the airflow that you would in a spray room as you would in a spray booth, which is the 100 feet a minute. Another good use of a spray plenum is to run it the other way. As instead of exhausting, you could put intake filters and you could bring fresh air into a room and use it as an intake, filtered air intake. So in that instance, because you're blowing air in and not sucking air out, you wouldn't have code requirements requiring it something to be a spray room. So if you wanted to ventilate fresh air in or bring in makeup air and disperse it out through a plenum, that's a good use that you'd see that for as well. So if you have any booth in a room, you're going to normally have the 100 foot per minute rule in any cross draft type. And if you have a non-human robot, we typically can slow the airflow down because there isn't the OSHA requirements for how much air has to move in front. Okay, next booth on the list is probably the most common one that we sell in the market for industrial and both wood and metal, and that's the open face booth. Why would an open face booth be legal and a plenum not?
Containment?
Yeah, exactly. So anytime you put three walls, let's say, right, like you're making like a vent, you're now adding velocity to the air, because anytime you give air a constriction, it speeds up. So the mere fact of putting the walls on those filters, and they need to stick out 6 feet to be legal, just so that you know, you now have a classified area that's 6 foot deep by however wide by however high, that is now considered a spray booth because the velocity of the air has sped up in that zone, and it will contain the overspray. So this is the reason why an open face booth is legal as a spray booth and a exhaust plenum is not. Does that make sense?
Mhm.
So this works by drawing air horizontally over the object to be painted. Typically, air is drawn directly from the shop environment. Only three sidewalls are required. So you're still going to have the 100 foot per minute airflow requirement, 60 with a robot. Now, something you can do quite easily, you can add filtered doors to an open face booth, and then that gives you an extra layer of dust protection, so you're not getting dirt and grime into your freshly painted product. Something I didn't put in this, but you can also put vestibules on this type of a booth, which would be an opening from the left and right where you might run a conveyor or a cart through. And you would want to have the vestibules stick out left and right a few feet. And that is because air can change directions and bend around things, but a particulate like dust or dirt cannot. It has to travel in a straight line. So putting a vestibule on would help reduce contamination in a conveyor or slot opening. So we're still going to have the same airflow requirements, whether there's filtered doors or not. Okay. Then the next one out there is a cross draft booth, right? So everything that we go through from here on out will be offered in a non-pressurized and a pressurized version. Non-pressurized simply means it's passive as far as intake air. It's going to just have shop air or ambient air pass through filters typically. And then, and as you can see in this case, it goes across the entire booth and goes out the exhaust, up the plenum, and out the exhaust stack. This is probably the most common spray booth in the world because of the automotive painting industry. You pull a car into this, pulls it across, and away you go.
I have a question on the open face.
Mhm.
What about where there's a conveyor on it? Does it still need the 6 feet of
Yes.
paneling?
You
Okay.
need at least 6 feet of depth for an open face booth to be considered legal. You can make an open face booth as deep as you want. I've done them 80 foot deep before. There's no rule about how deep, but there is a rule of how minimum, I guess, there is of deep, no maximum.
Thank you.
Mhm. All right. So same as an open face booth or one with filtered doors. This works the same way. Air is drawn in from the shop environment, goes across filtered doors, travels across the booth, and goes out. You can do different kinds of intake filters to get different mesh or different capabilities to get finer and finer particles. You're still going to have the 100-foot velocity requirement. Okay. Then you can also do what's called a pressurized cross draft booth. So this picture shows the interior of a pressurized cross draft booth. So what is happening here is the filters closest to you in the photo on the right are intake filters. There's a fan sitting on top of this booth. It's blowing air into that plenum with positive pressure. It's going across to the back of this photo and out those exhaust filters. Those are paper type exhaust filters. Does anybody have any questions on this?
What's the advantage?
Well, when you pressurize the booth as compared to the room that it might be in, you have positive pressure. So you're not sucking dirt or dust in if underneath a door seal, or if someone opens the door, air will rush out instead of rushing in across a freshly painted product. Also, this photo, those plenums, both on the exhaust side and the intake side, are called pant leg plenums. And there's a bridge that goes across. You can't see in the photo, but it would be on top of the roof panels. And that's where the two fans are, one blowing in, one sucking out.
Mm-hmm.
And so that's called a bridge plenum or a pant leg plenum style booth. Rather than just having a solid wall of filters across one end, you're using pant legs, they call them, to get the air in or out. That works well for, just like shown here, this is what we would call a drive-through style booth, where you could have product doors on both ends of the booth and move product in and out.
Gotcha.
Best for high-end finishing too, correct?
It's higher in than non-pressurized, but I would not consider the cross draft booth a high-end finishing booth, and we'll get into that. But this does a lot of the work in the industry. So we kind of reviewed, this is the same as the non-pressurized version. Oops. Why would this not be considered a super high-end finishing booth or style of booth?
I don't know.
Well, this drags the overspray
Okay.
from one end to the other across your own parts. So if you had multiple parts in here, the painter would have to be very careful in the manner in which he sprayed, so as not to get overspray on his already painted parts or his about to be painted parts, which can leave that fine dust.
So
So-
it's very directional.
Very directional, yes. So this is the least expensive way to move the required amount of airflow, because you only need one fan, and the cross section of how you come up with the CFM is the narrowest. But you are dragging your own overspray across your own parts.
Makes sense, Ty. So a downdraft would be better then,
Correct.
I guess. Okay.
Yep. So we're gonna get into that. Sorry, I have to redo these bullet points because I hit the backward button. All right. The next one, you don't see it a whole lot, but it's my nemesis of all spray booths, because people market this and try to basically tell end users that this is as good as a downdraft booth, and it's simply not. This is what you call a modified side draft or modified downdraft booth. In this case, it's the non-pressurized version. We'll come to the next slides and there'll be a pressurized version. But can anybody from looking at this diagram tell me why this would not be a great choice for a spray booth.
Again, it's directional.
Yes.
It's the same thing, though, overspray also, right?
Yep. You will drag overspray across your part. Absolutely.
Yep.
Faraday airflow.
Yes. So air, just like water, takes the path of least resistance. So if I'm introducing my incoming air on the top of the ceiling, it's going to have far more air velocity go right across the top of that booth and out to my exhaust wall, right? It's not going to come down to the floor and sweep across. Whereas if I have a cross draft booth, the entire area is going to evenly pull
Mhm.
air across the booth evenly. This is going to leave a huge, almost a 45-degree angle void at the front left. I don't really have a mouse that I can draw on here, but if you were to look at the bottom left half of that and draw a line at a 45 degree, you'd have a complete dead zone where there's almost no air movement. So I would never sell this type of booth unless I could help it, because you end up giving a customer a booth that has a third of the booth with almost no airflow.
Hey, Tide, is that one of our draw? Did you draw that up?
No, these are some stock images, and I went out and found resources on.
I was
I
gonna
had Alex mark them up a bit, though.
have green arrows on the top and red arrows along the bottom by the wheels, just to
Mm-hmm.
picture itself would be worth 1,000 words. I mean, that's the first thing that came to my mind. I went, okay, now I get it.
Right.
That's cool.
So this is normally when you're in a quoting scenario and you've gone out and quoted, let's say, a real side downdraft booth. A lot of people will go on the internet. They'll be like, "Oh, this is a modified side draft. It's the same thing." It is not. This is a cheaper way to try to make you think the air is going to move in the downward motion. It does not move in the downward motion. It's doing the same exact thing as a cross draft booth and dragging your overspray across the part. Still must carefully plan your path. You still have the same airflow requirements, right? So here's the same booth but pressurized. So in this case, you can see we've added a heated air makeup, which is grabbing usually outdoor air, which is the blue lines, going across to burner, firing that off so it's heated, and then we're adding the hot air now through that plenum in the ceiling and out across. Okay, so this is not like a downdraft booth, and you have a large dead air zone at the lower front of this booth. Something I like to do anytime I'm standing in one of these type of booths, if you want to prove that effect to a customer, go get a piece of cellophane or saran wrap or something like shrink wrap, pull a 3 or 4 foot piece, walk into the booth, shut the door, turn the booth on, and stand in the front of that booth. That cellophane probably won't move. If anything, it'll probably go backwards opposite the way of airflow, because there's normally a little eddy current going the wrong way. And then as you walk closer to the plenum, watch how it speeds up and then moves out.
Hey, Ty, then why is this booth available?
Because people who sell spray booths like to sell spray booths.
It's just a concept. I mean, it's proved itself to fail. I don't understand why people would be.
It's a concept that people try to sell when you're selling a real side draft or a real downdraft booth. They try to present this as an alternative.
Gotcha.
So part of my education for anyone watching this is to be aware of this airflow design. It's very, very common. All the spray booth manufacturers offer it because it is a common spray booth design. And, you know, some people will specify or request it, right?
I imagine, Ty, it's a little less costly.
Less costly than side draft or downdraft, but
Yeah.
if you're going to go to the expense and you're on a budget, I would much rather sell a cross draft or a pressurized cross draft booth than any time. I would never sell a modified side draft.
Yep. Mhm.
But we run into this several times a year, and I like to, make sure you guys are educated on what's out there and why we don't sell certain things.
So I got a question. You mentioned heating the air makeup air. Can we also cool it?
Yes, and we will get into that in a little bit. I have a section on that.
You know why I'm asking?
Because you live in a hot environment like Arizona. Yes,
And
but we're
Texas,
going to
of
get
course.
there.
And humid.
Yep.
Yeah.
Okay, so probably seen as the best style of airflow is downdraft. Okay, so this picture shows a non-pressurized downdraft. So the blue arrows are pointing to just a passive filter system normally across the entire ceiling. You're pulling that air straight down. Normally, a downdraft booth has a pit dug into the concrete. Then that pit goes over and meets an exhaust fan. So your plenum is essentially in ground or in the concrete, and then you're exhausting that air out. Why would this airflow be good?
Takes all your solvent and everything away from you completely. Very safe.
Yeah,
Less.
and overspray doesn't be floating up in the air.
It's not being pulled across your part. It's being pulled straight down to the ground. So it's the absolute shortest path for the paint to exhaust and least amount of to go across and contaminate your own parts with your own overspray, right?
Right.
Okay. Another thing is because it's going in the downward motion, you also have the effect of gravity working for you, right? So it's accelerating the flow. Gravity's one of the strongest forces in the paint booth.
Yep.
So this causes minimal overspray to pass the part. This is generally seen as the best possible quality of spray booth. So if you said very high end, this would be it.
Is there any problems with paint buildup in the section that's in the concrete?
So yeah, there is, it's not as easy to access, obviously, if it's below ground. There is normally grading on these types of booths, and the grading can be very heavy to pick up, and then the filtration is underneath of that grading. So you normally do roll media, and you get on a schedule. It's not as easy to change the exhaust filtration on this type of booth as compared to cross draft. That is a absolute good point.
Is this option fantastic for high production? Can you do it on a conveyor-like system?
You could put any conveyor through any booth, really.
Okay.
There's nothing that says one type of booth only for conveyor.
Okay.
Yes, I guess production normally, if you were like at a automotive production company, this is going to be the type of booth that they have.
Okay. Factory. Yeah.
Mm-hmm. Okay, because we have the benefit of gravity, we normally only have to have a 50 foot per minute average velocity through this type of booth. Now, there's some inspector-driven clouds around this because officially the code says any spray booth needs to have 100 foot per minute face velocity. It's generally accepted in the industry that a downdraft booth, because of the effect of gravity, that you could do it with 50. So once in a great while, you get a very odd inspector that will call out or require 100 foot even in a downdraft booth. But there's certain codes you can refer to called like the LTL to figure out the air in the building and how many changes of air has to happen to be under the lower LFL, I should have said, lower flammability limits of the building. But normally we would start with 50 foot per minute in a downdraft style booth.
So I have a question going back to the running a conveyor through any booth. Would you run one through a pressurized booth?
You can, yes.
How does it keep pressurized then?
So anytime we're pressurizing a booth, we normally use a magnehelic gauge, and a room pressure sensor. So it's chasing a set pressure. So we sort of would plan that the opening would be there, and you figure that in. Now, we don't want to be blowing a bunch of air out of a spray booth. You normally are going to keep it balanced or very slightly positive. You're not going to be, having air blowing straight out of a booth normally.
Okay.
And then also what we talked about earlier, if you have a conveyor, you're always going to want to add a vestibule on the inside and the outside of the conveyor so you can prevent any contamination from coming in that conveyor slot.
Hmm.
So if we're not going to have people in the booth, we can slow the air down more. So robots and automation can use less air. Why would that be important to know that we could slow the air down if we're not going to have humans in a booth?
That affect the size of fan that we need to exhaust everything?
It could. We normally are going to put a fan in any booth that's large enough so that we can run it for a human to be in there, because inadvertently someone's going to need to go in there and spray. But we'll normally put a VFD drive, a variable frequency drive, and we'll be able to slow that fan down. The reason and what I was asking is the cost of putting in replacement air, especially if it's heated or cooled, is pretty significant. So if I can use 20 or 30% less air because I have a robot in, all of my costs go down significantly for gas and electricity and fuel to make that air.
Does it also affect how can I say? Does it lower paint costs because more is getting to the part rather than zipping past it?
It can, especially if you are using electrostatics and that kind of effect, because the electrostatic will be able to turn around and wrap better if you have less velocity of air
Right.
or powder. Okay, so here's a pressurized version of that same booth. So you can see on the left, we have a heated air makeup. Normally that can sit on top of the booth, on top of the building, or outside of the building on a stand, which is what's shown here. That is taking ambient air. We're going through some V-bank filters, which looks like a W there on the drawing. Goes across the burner section. It's heated by the direct fired flame. Goes in across that ductwork into the plenum of the booth, which is across the ceiling. Down we have hot air pushing straight down to the floor, wrapping around the vehicle, out that pit, and then as you can see, up the exhaust fan and out the exhaust stack through the weather cap and on top of the roof. So that's a pressurized version. Same thing, overspray's pulled to the floor, shortest path of paint to exhaust, gravity helping us, minimal overspray. Generally, this is seen as the very best possible quality of booth. So we have a couple of brand-specific solutions that use this downdraft design. So one of our vendors is AFC. They've been building spray booths, I think since the 60s. This particular photo is taken at Orange County Customs, I think it is. There's a little video on this coming up. And this is their quad draft booth. That is a brand, name specific, but it is a type of downdraft booth. And we'll learn a little bit about it. If you get into a shop where you have a very, very high-end need, normally these are automotive shops, by the way, which we don't do a lot of body shops in our world. We're much more industrial, but we do come across it occasionally, and you shouldn't be afraid to walk into any kind of body shop as well.
Hi, I'm Ryan Friedlinghouse, CEO of the world famous West Coast Customs. Over the years, we've strived to be the premier custom car shop. We've built cars for the biggest celebrities, athletes, and corporations. Our motto is, if you can dream it, we can build it. One of the things we pride ourselves with is delivering the best paint job out there. And the only way to do this is having the most talented painters and the best equipment. When you're painting high-end cars, you definitely have to have a high-end booth. That's why we choose to have AFC paint booths and prep stations for our facility. The Quadraft fits all of our needs. It has a turbulent-free airflow, which prevents any overspray from hanging around. It has 4 exhaust fans for a cleaner environment. The floor is fully graded, which helps keep it clean. And the heaters work fast, which definitely speeds up our turnaround time. The other important factor we took in consideration when choosing a booth is the company. With AFC Finishing Systems, I know we have a company that will support us. From great customer service, quick booth install, and user-friendly control, AFC has it all. The booths look great, and they're the brightest booths I've ever seen. AFC Finishing Systems, when only the best will do.
So that video is on our website if you ever needed it. Here's another video we'll watch in a second, but the reason this booth is called the Quadraft, and he quickly showed it there. There are 4 exhaust fans on this booth, on all Quadrafts. So there's one for each quadrant, if you will, right? If you divided that booth in half and then in quarters. So each fan has its own VFD, and it's set to pull an even amount of airflow and self-balance, essentially. So no matter what is happening with filter load, or if there's a car or a larger part over one part of the booth and not the other, it would self-balance and get you even airflow. The walls themselves are double paneled and hollow, and they're actually exhausting the air through the walls and up and out through each quadrant. So I think this video will show a little bit more on that, but it's a very cool, innovative design.
Paint job may be one of the last things you do to your car, but it's the first thing that you see. Hi, I'm Chip Foose.
And I'm Charlie Hutton.
We're standing inside our AFC Finishing Systems Quadraft spray booth here at Foose Design. The Overhaul on TV show started working with AFC in 2004 at the SEMA show. We have a very demanding build schedule on our show, and AFC managed a miracle. They set up a Quadraft spray booth outside in the parking lot at the Las Vegas Convention Center. The booth performed flawlessly under these very unique circumstances. I had AFC install a Quadraft spray booth here at Foose Design shortly after the SEMA show. When I think of the name Foose, I don't only think of my family name, but I think of a group of guys that get together to do their best in building a car. Our name is on every vehicle that comes out of Foose Design. Obviously, we're only interested in products that perform at a very impressive level. The Quadraft spray booth meets all our demands. Charlie, tell them about it.
The superior airflow with up to 19,000 CFM utilizes the exclusive disperser plan, ensuring even airflow into the booth. The unique design of their exhaust system creates a turbulent-free environment with no updrafts, virtually eliminating the need for cutting and buffing. AFC's use of quality components ensures a long and trouble-free service life. The booth has a durable powder-coated finish and includes a fully automated touchscreen control panel and an array of color-corrected light fixtures creates the brightest spray booth I've ever seen.
The Impression, Ken Reiser's 2005 Riddler Award winner and the 2006 America's Most Beautiful Roadster Award winner, was painted in our AFC Quadraft spray booth. The results go without saying. AFC Finishing Systems is an impressive company to work with. Their support throughout sales, installation, startup, and follow-up has generated a reputation in the industry for outstanding and unparalleled customer service. I want the best finish that we can possibly get on the cars we build here at Foose Design. AFC gives that to us. If you want the best, go for the best.
So did you get a little look at more how that booth works?
Yes.
Any particular questions on the Quadraft?
What's the low end price?
That's you're always going to get a quad draft with 4 fans. You're always going to get it with heated air makeup, recirculation, and bake. You're probably in the 100,000 plus range for a booth like that. It's always double wall, powder coated, insulated, every bell and whistle, PLC controlled, touchscreen. It's pretty nice.
It's nice.
So this video, so we have another manufacturer we deal with that does also very high-end automotive out of Italy. They're called USI Italia. They're seen as probably the highest end automotive spray booths that I've ever come across. Very, very nice. They have some innovative features. This video hasn't been working for me when I go to play it. So Jad, I sent you an email with the link to this. Can you play this video real quick? Are you there, Jeb? Chad? Nope. Here we go. So if you don't have the room for an above ground or a below ground pit, you can do what's called an above ground downdraft booth, where it has an elevation normally 6 to 8 inches high that sits above your concrete, but you have to have a ramp. Normally people have had ramps that you drive up from outside of the booth, but that takes up room. So I wanted to show you guys something that's pretty cool that these guys at USI Italia had come up with. So you drive in, and then this is a hydraulic ramp that will lift an entire car up if you had to. And you can see, your car is sitting up above, and then that becomes the exhaust plenum down below there. And that's all internal with inside of the booth. No one else I've ever seen has had something like that before.
That's nice. How much does that onto the cost?
I don't know that I can say that what it exactly adds to the cost, but it's just part of it. All right, are you seeing my screen again? Okay. All right, so you've got your non-pressurized semi-downdraft booth. So normally you're going to have on any I'm sorry, this is semi-downdraft. Sorry, yes. Previous was just downdraft, so that we know the difference. What's happening here is we're going to have at least 2 fans, one on the left side, one on the right side, and we're going to have exhaust filter plenums running the entire length of the left side and the right side walls. They're not in the ground, they're above the ground. Does everybody know what I'm talking about here?
Mm-hmm.
I think I've got some photos. So this becomes a little more of an economical situation, and we probably sell more of these than we do a downdraft booth because of the issue with the pits that we just discussed. This still gets you a really good airflow where the air is going down, but instead of going to the center or out the floor, it's going left and right at the very last minute, sweeping across the floor and then going out your exhaust fans. So you still get that downdraft effect. Still going to have your 50 foot a minute required airflow, just like a downdraft booth. Still have the benefit of gravity assisting you. Same with the robot, you're going to have a lesser airflow. Okay, so something to consider with any downdraft booth or side downdraft booth, or even a cross draft to be aware of, is the size of the object in the booth can affect your airflow. So I never consider the size of an object in my airflow calculations, and I think that's the right way to do it, especially when you're dealing with mostly industrial customers that might bring a product in the size of a cabinet door or small, tiny parts versus a bus manufacturer, right? So you have to be aware when you're selling spray booths. There are people who make their living doing this, just selling online without making actual sales calls in person to people. And they will sell airflow at, say, 35 foot a minute if it was empty. But when you put a semi truck or a bus in there, oh yeah, now we're at 50 foot a minute, you're fine. Well, what if I want to go spray a man door? Now I don't have the right airflow, I'm illegal. That's just a little trick that these internet companies do on spray booths. Does that make sense to everybody, what I'm talking about here?
Mm-hmm.
So when you look at a specification, you should see what the airflow in feet per minute is, or do the calculation yourself to figure out what their airflow calculation is. Okay? Because a lot of times I've found people that on a booth that should be 100 foot a minute, they quote at 50 or even 30. And then when you question them on it, they say, oh, well, we're going to take up 70% of the air by putting a bus in there, right? Well, you're not going to paint a bus every day. So I always do my airflow calculations assuming an empty booth without any displacement inside of the booth. But people will use displacement in their calculations, so you need to be aware of it.
Hey, Ty, are you going to talk about the meter that can be used to show the airflow too as well?
I don't have it in this presentation, but we can talk about it right now. So there is a meter called a velometer. It looks like velometer when you spell it out. You normally hold it a foot or so from the exhaust filter. If you had a grid of filters, you want to normally go in front of every other one and make kind of a grid pattern. And it spins like a fan, and it measures how fast that fan is spinning, and it tells you in feet per minute the average velocity of the air. So to measure the air velocity in a booth, you would take an average reading with points all the way across your filter area and then divide it by the area, right? So you would figure out, I have 10 cells that are moving 125 foot a minute and 8 cells that are moving 80 feet a minute. You add those up, take the average, and there's your average velocity in the booth. So that's how you can do a physical reading on an existing spray booth and figure out how much actual airflow that they're moving.
Is that with fresh filters, or let's just say partially used also?
So the meter will tell you at current state if it's full or clean, right?
Sure.
We're gonna get to that in a minute, but I'll skip for you there. We have to figure that 100 foot a minute rule, or in this case 50 foot a minute if it's a side downdraft, that's with full filters, right? So a filter normally has a static pressure rating. The most common in the industry is a 1/2 inch of static pressure. And so when you exceed a 1/2 inch of static, you change the filter. So that means I have to move 100 feet of air a minute in a cross draft booth with a fully loaded filter, which gives me a 1/2 inch of static pressure resistance. So at 0 or 0.004% or whatever a new filter is without paint in it, I'm going to be moving 125 foot of air a minute instead of 100 when it's full. So there is a calculation, and that's to do with static pressure, which we're going to get to.
Well, isn't there a device, I forget the name of it, but it's a differential measurement that automatically detects when the filters need to be changed, because it has a sensor on the face and then a sensor in the plenum.
Yep. So There is just what's called a manometer, which is a requirement of every
That's
spray booth to have. And it simply is a water column gauge, right? So there's nothing mechanical really about it. It uses water that's dyed normally red or green, and it shows you on a metered scale the high side of the filter versus the low side of the filter. And it's basically it's what it's doing, just what I said. It's measuring the static pressure. So when you get to a half inch of static pressure on the gauge, on the manometer, you change your filter.
I'm very familiar with the manometer with gas pressure. How do you use a manometer for air pressure? Is there a cone that collects? I'm just trying to picture.
It's just a piece of tubing that's on each side of the filter. So one's on the low pressure side, which would be the exhaust fan side. The other is on the spray booth side in front of the filter, right? So one's behind the filter, one's in front of the filter. And then essentially you've got this water column, and as one side overpowers the other, it'll pull a slight vacuum on that water column and move it in the direction of resistance on the gauge. Does that make sense?
Yeah.
So it's not a mechanical, there's not like any motorized or electronics to it. It's literally just a vacuum of one overpowering the other versus water.
Yeah. Okay.
So what you do when you have new filters, you set the manometer to 0 on the gauge. And then as those filters load, you'll see that water column start to shift towards the rise. And when you get to a half inch, which is, it's usually measured in 1/8 inches as it goes. When you get to a half inch of static, that's when you would have a mark on there to change your filters. Okay, so next slide here is a pressurized side downdraft spray booth. So this is just like the other one, but now we've added the air makeup, and the air makeup could go outside on a stand as shown here. It could go on the ceiling of the booth. It could go on the roof of the building. Those are your kind of normal places to put an air makeup. Same thing comes in with hot air through the plenum, goes across the part, goes down, and then goes left and right. To each left wall and right wall of the booth, travels the entire depth of the booth, and then is exhausted out. So easier to do than a pit type booth.
So a lot of these options, it's the budget of the customer too, correct?
Yes, absolutely.
And also the demand though too at the same time.
Mm-hmm. Okay, so here's some photos of side downdraft booths. So this is actually a booth we did in the Bay Area. You can see in the ceiling, there's the filtered tempered air coming in, and then it's going out. In that instance, it's showing you to the right side down along the floor. Here's more of a typical truck booth where you see coming in from the top, going out the left, going out the right. Here's that same booth that's in the center now shown, so you can see both left and right side. There's an outside view where you can see that plenum on the right side sticking out along the bottom, and then you can see the exhaust fan going up, out, and then you can see the bridge of the air makeup coming in to feed that plenum across the top. The air makeup in that one is mounted on top of the booth. Any questions on the side downdraft?
Seems like a really good option for me. I mean,
It's one of my favorites. If the customer wants to be better than a cross draft booth, I almost always will move them into a side downdraft booth. Pits they're the pits. They're just a pain in the butt. You've got to get into concrete cutting, pouring, engineering. It adds a ton of expense. You get into this, you can put it on a level piece of concrete and away you go. really automotive guys are the only people that are really requiring pits.
Mm-hmm.
All right, next we're going to get into powder booths. Okay, so the least expensive type of powder or dust collection booth you can do is called a bag filter style booth. So this photo, you can actually see there's pocket filters in the back. This is cross draft style. The dust or powder is collected in those specialty filters that are like bags. That's why it's called a bag filter booth. Once those fill up with powder and you lose static pressure, or you get static pressure and you lose airflow, you take those bags out, you throw them away, and you replace them. They're fairly expensive. But this is the least expensive type of dust collection booth, and what you have to educate your customers on, because there again, people click online, they see a powder booth, and this is what they buy all the time. So those filter bags are like $40 a piece, and you can see how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 16. There's 20 filter bags in that booth right there, which is just a typical little 10 by 10 booth. So you're going to change those out probably weekly. 20 times 40, that's $600 a week in filters. Okay. Airflow in a powder booth or dust booth is normally done in feet per minute, but there is a calculation depending upon what it is that you are trying to collect. Because dust, unlike paint, sort of changes in weight, right? If I'm taking powder coat, I probably only need 50, 60 feet a minute to get it to go across the booth and go where I want to collect. If I'm blasting in a booth and I've got steel shot, I probably need 100 or 120 foot of air a minute in order to get that heavier shot to travel and go across where I'm trying to get it to go to collect. So the weight of the media that you're collecting has to do with the calculation of airflow when you're talking about a powder or dust collection type booth. And that's any type of powder booth. Okay, the next type of powder booth, and this is the more common one we sell, is a cartridge type booth. So instead of those pocket filters, we have these large cartridges, which about 50% of them are hidden in that photo, but you can see the 6 of them hanging down there. They collect the dust all the way around. They're kind of like a pool or spa filter. And then every so often, there's a program that runs a compressed air blast, and what they call a reverse pulse, and it goes backward through those filters. It pushes the dust that's been collected out, and it drops it straight down into those trays underneath of them. So those cartridges will last for a year or two in some instances before they have to be replaced. They're only $150 or $200 a piece. And so you don't have the constant maintenance of changing the filters like you do with the bag filter type of booth. Does everybody understand a cartridge style booth versus a bag filter booth?
Mm-hmm.
Seems much better. Is the
Yes, much better. But let's just say in a starter instance, a bag filter booth might be $15,000 or $20,000, and a cartridge booth might be $50,000 or $60,000. And if you're a powder coater starting out, the want to buy the cheapest booth possible happens all the time. They do. And the problem is they don't realize the maintenance cost ongoing of a bag filter booth will eat them out of house and home. So it's kind of a pay me now or pay me later scenario, but people buy that bag filter booth 5-to-1 over a cartridge booth, but then they got to throw it out, or they got to try to hack into it and put a cartridge module into it later, or, deal with the problem that they've created.
Now, does one filter better than the other?
They're both rated to contain the dust. Powder and dust collection sanding booths don't have to exhaust outside. You normally go through 2 or 3 layers of filtration.
Oh.
Back up here. and it just dumps right back into the building. It doesn't go outside, so you don't lose heat with these or anything like that.
But does all of the NFPA 33 apply to this also?
Yes, it does.
So is the powder that is shaken off in the cartridge booth, is that powder reusable? Is it collected and reused?
Great question. So we have what we call spray to waste booths, where you just let all the different types of colors and powder mix and you throw that away. Or we have reclaim booths. And essentially with a reclaim booth, you would have those cartridge modules normally on big wheels, and they unclip from the booth. You wheel them off and you wheel another color on and clip it on, because you want to keep them separated. So you might spray black for a couple of days, wheel off the black and wheel on the white, click it on, and now you're going to reclaim the white. But you're never going to clean a single cartridge out good enough to reclaim. So you normally do an entire replacement module for each color. Make sense?
Yeah.
So if we want to get into color changes that are a bit more efficient, you would get into what we're showing here, which is a cyclone type booth. And so I think most of you know we have a partnership with Erzinger out of Brazil, and they make cyclone type booths. There are really only 3 or 4, 5 maybe manufacturers in the world that do this type of powder booth. You have, Wagner, Gema, Nordson, the big 3, and now we've got Erzinger that we brought into the market. So this would be what we showed at FabTech last year. You have a PVC booth. So instead of being made out of metal, it's made out of PVC, which is non-conductive. So when the powder is sprayed, it's not attracted to the walls. When I go to do a color change, I can blow down the walls quickly and reclaim all of the powder. It goes through the bottoms. We have that downdraft type airflow design, which we know is the best. It goes out the ductwork, up through to the cyclone, number 2 there. Cyclonic effect spins that around. And what happens is the dust collector that's on the top pulls off the fines that are too light to be traveling by gravity downward. The good powder is heavy enough that it travels down that spiral, goes to a sieve or a screen, is screened out to make sure nothing of debris is brought in. And then we pump that good powder that's reclaimed back to number 4, the paint kitchen, and we can reuse that powder over and over again. And we can also do a color change in just 4 or 5 minutes. Any questions on that general overview?
Nice.
So same type of airflow requirements.
Ty,
Yes.
with that, do you think it's good to cover that the powder isn't reclaimable forever? Like how the cyclone works?
Sure. There's a video we're going to watch first, and then we'll get into that. So this is a video of that exact booth that you just saw, of the operator doing a color change, so that you guys have an idea of what it's like to do a color change in a powder booth. Oops. He's blowing the powder off the gun themselves. He's blowing the walls of the booth down. So that was a complete color change and a cyclone type powder booth. The question that Dallas asked just before, in all powder booths, doesn't matter if it's a bag filter booth, a cartridge booth, or a cyclone booth, there's an effect on powder called powder fusion impact. And that basically means every time that powder hits a surface, it breaks down a little bit. And when you're charging the powder with electrostatics to make it wrap, at a certain size, as a particle gets smaller and smaller, it will no longer hold a charge. So what can happen over time in any powder system is people reclaim the powder over and over and over, but they never put in new or get rid of the tiny fines that are out of it. And you'll get this buildup of powder that essentially cannot hold a charge and just is dead in the system. So it's important to always be adding virgin powder, and it's also important that periodically you actually dump the reclaimed powder and start over, or you're essentially just chasing your tail because of powder impact fusion and breakdown of the powder size.
Can you mix the old with the new size?
Sure, but you're still, once a powder has become too pulverized, it's just going to travel around in the circle and not hold a charge and go out on the part like you're asking it to.
Okay.
So occasionally you need to start over, even if you reclaim.
And the cyclone separates it.
The cyclone will pull the fines off and goes out to that dust collector. The dust collector has cartridge filters in it, and it dumps that to normally a 55-gallon drum of waste. A cartridge booth and a bag filter booth never deal with the fines if you're reclaiming.
Is this the only company we have a color changer with?
Wagner has a color change for powder, MS has a color change for powder, and Erzinger has this. this is the most economical one, but we have multiple sources for it. In as far as a cyclone type booth, we have many sources for cartridge type booths.
Okay.
Yep. Any other questions? I have a brief section on ovens, and then we're going to get into some more commonly asked questions about everything we've covered. So we do ovens. Normally that's part of, if you're getting into powder, the next thing you're going to sell is an oven. Oven comes in all kinds of shapes and sizes. We do them for horizontal applications. We do them for batch. We do them for inline with conveyors like on powder systems. In the generality, ovens have essentially the same requirements that spray booths do. Same setback requirements as far as property lines, as far as electrical code compliance. All of that is pretty much the same. You can never share an exhaust stream with another device with an oven. You'll need to know that if there's an air quality district, especially in California these days, you'll have what's called a low NOx requirement, which is essentially an afterburner on the burner that tries to burn some of the spent fuel to reduce the carbon footprint that's going out. Those kind of low NOx burners add a lot of expense, and they also are going to require source testing or a third party to come out and certify that the customer is indeed using that burner in compliance. And that's nothing that we do. That's just something that an AQMD is going to require. Those same low NOx burners are also required on heated air makeups, and they have that same third party testing normally required. There's people who that's their entire business. Any questions on ovens?
You still there?
Yep.
Oh,
Okay. So frequently asked questions sort of about everything we've covered. Okay. So I don't know if everyone has ever read our quote format, but most of this stuff is in our quote, just so that you know. But how far away from a property line does a spray booth exhaust need to be? Anybody have an idea?
30 feet?
That is correct. The NFPA gives us that specification. So when you're out surveying a customer's site, you need to ask, where's this going to exhaust? Go outside of the building, look at the property line, and if it's too close, you're going to have to go out of the building and then run, diagonally or away from the property line until you've gone 30 feet before you can then go up and exhaust. How far away does the intake need to be from my exhaust? So if you have an air makeup intake back into the building, how far away does that need to be from the exhaust?
10 feet?
Close.
Okay. 12.
It's 15. But here's an example where this was a booth in Montana we did years ago. And if that intake had gone right next to where that exhaust is shown, if the exhaust had gone straight up, that would have been too close. So we had to run the exhaust over and away from the intake so that we didn't create a loop of exhaust going right into our intake and creating a cycle.
makes sense.
Can a spray booth touch a building wall, or is there a space required for egress? Any questions? Guesses?
3 feet.
3 feet?
Well, can a spray booth touch a building wall? I guess is the first compound part of that question.
Well,
No.
Well, the answer is actually yes. So if the wall is 2-hour fire rated, a booth can touch the building wall. If the wall does not meet that 2-hour fire rating or construction rating, you must be then 3 feet from the wall or ceiling. So that would apply to a ceiling too. If you have a low ceiling, that ceiling would have to be 2-hour fire rated, or it has to be further than 3 feet away from the top of the booth. Kind of a good little thing to know, 2 layers of 5/8 drywall, normally staggered and fire taped between layers, will meet a 2-hour firewall construction. So if you have somebody who wants to put a booth right up next to a wall and it's made out of a wood, or it only has a half-inch sheetrock on it, you can normally get a permit to touch that wall if they put 2 layers of 5/8 sheetrock and fire tape it. So it's much less expensive than trying to build a masonry brick wall or cement wall that's non fire combustible.
It's very close to restaurants in like up against demising walls.
Yes, very similar.
We used 3 layers of 5/8, and that gave us even more than a 2-hour. But this is good to know, and it is a real simple solution for people that are in a wood.
I will tell you, if a customer is going to do that sheetrock thing, he needs to take photos of it as he builds it, because I've had him make him tear it off and show the inspector how you did it. So,
yeah,
taking
photos. Yeah,
yep, exactly.
Well, that should be part of the inspection, though, too, Ty. From the permit, the building department should be able to specify this is who's all going to be involved. So
right.
Okay, cool.
Okay, here's one you get all the time. Do you need a respirator if you have a spray booth?
Yes.
Absolutely.
Yeah.
So, number one, it is always up to the painter first to wear a respirator, and then the company he or she works for to determine whether additional PPE is required. We would never tell the painter not to wear or use a respirator, or for that matter, any PPE. Now, some of these large companies have done extensive studies for airflow, and they've determined that it's safe to spray in the booth without a mask. That's up to them and the employee. We would never put our endorsement on it. If asked, wear a respirator.
Yeah, it's in some cases with the downdraft, they claim that they are, but I can still smell it.
Yep. Well, if you can smell it, you should probably not let it in your body, right?
Yep.
Another thing to know, if a customer is spraying urethanes all use isocyanate to catalyze. Isocyanate is very dangerous, and it enters through your eyes. So a respirator will not do the trick. You need to wear full face, something that covers your eyes.
Oh, mask.
Around isocyanates, yes.
I thought it enters through pores in your skin too, Ty.
It can. There's certain catalysts that can, but a lot of people only just put on a half mask, and they really got to be wearing a full face with eye protection.
Yeah, but I thought if you're doing that, I thought you have to be wearing those Tyvek suits too.
Best practice, absolutely.
Hoods, boots, works, and gloves.
Absolutely.
I thought some folks are using diisocyanates to eliminate a lot of the hazards.
Still mask them up.
Yep.
Suit up. Okay, here's one I get asked all the time. Do all paint booths require fire suppression?
Yes.
Yes.
Absolutely. Yes. Even if the customer uses water-based or powder coating, there is no guarantee that we'll use water-based paint tomorrow. The government requires it. The government doesn't care. Also, if it's powder or dust, that is flammable. You get in the right combination, it can be explosive. And so therefore, it's required to have fire protection on any spray booth. Can I share an exhaust stack on a spray booth with another booth?
No.
Correct. So any volatile airstream cannot be shared with another stack, right? So if I have a booth 1 and I were to go over and put it into booth 2, the concern is I might turn booth 2 off, and it would therefore blow everything back out into that booth. So anytime you have volatiles in your airstream, you cannot ever share an exhaust stack. Now, I get that in HVAC world, when they're dealing with fresh air that doesn't have any volatiles in it, they can share exhausts. When it comes to the world of paint booths, that is a no-go, never. Always one booth, one exhaust, or multiple exhausts on one booth, but they never share a stream, even on the same booth. Do I have to exhaust my liquid spray booth out of the building?
Yes.
Doug knows this one really well. So this is a bit of a trick one. It's 99.9% of the time the answer is yes. All of the water-based paints have solvents in them. The solvent-based paints have VOCs. That all needs to go out to the atmosphere to be gone. That said, there's an asterisk, all right? There are what's called abatement systems, VOC abatement systems available. And you need to be aware that we run into this occasionally, and there are companies that effectively market carbon filtration booths. They call them ductless booths or ventless booths. And they try to convince people that they don't need to exhaust a spray booth out of their building. Do they work? Yeah, they can. They're usually very, very cost prohibitive to actually keep and run in any kind of production. They normally will use carbon filtration in the exhaust plenum of the booth. The air travels through that carbon, just like if you've ever used like an old Binks carbon filtration respirator. You've got those carbon cartridges, right? The air travels through that carbon. The carbon captures the solvent, and you go through a pre-filter and that kind of thing. And then you have to dispose of that carbon after it's used, right? And you've ever heard when you're using a respirator, they always tell you to keep it in a Ziploc bag because it'll continue to absorb everything in the air, even when you're not wearing it. Same thing with this booth. Even when you're not spraying, it will continue to absorb in that carbon everything that's in the air in that booth and will continue to be used, right? So at that point, you then have these big carbon modules the size of spray booth filters that are a couple of, or maybe a foot thick, that are collecting VOCs all the time. And then you now have hazardous carbon to get rid of, or they will try to sell you a cleaning device that will essentially fire the carbon and try to get the VOCs burned, but you still have to dispose of. There's no good way to get rid of it, right? So
this is the good old afterburner, right?
Nope, haven't even gotten to the afterburner yet. I'm just talking about people who try to sell carbon filtration spray booths.
Okay.
Okay, so you need to be aware of it. There's also people who try to do partial carbon filtration and then a smaller amount of exhaust. In the end, I have never seen the math pencil for a carbon filter booth versus just dumping the air out to outside, right? It never pencils. Even when you consider I need to bring in hot air and fire off a gas air makeup and supply fresh heated air back into the building, and it just drives certain people crazy to pay for heated air. I understand the frustration, but it will never pay versus the amount of contamination and carbon and consumable and downtime and dealing with that carbon filtration. It just never works. Okay. The other kind of abatement out there for VOCs is what Sal had just said, thermal oxidizers. Okay. So a thermal oxidizer is a very large system. It essentially is an afterburner. Okay. So the exhaust stack goes through this afterburner. It goes across a big flame. It actually has big carbon ceramic balls inside of it that collect the gas. It goes over to a section that rotates to a hot flame, incinerates the VOC, goes over, cools, and comes back as kind of the big rotating thing. They're the size of semi trucks. They're massive. They burn natural gas constantly when you're firing it off to get that hot temperature to incinerate the VOC. And then after the incineration, you can put a portion of the air back into the building and close loop it. So you're looking at a small system starting at $500,000, and they quickly go up to $1 million, $2 million, $3 million, $5 million, like that. So those are the two VOC type abatement systems on the market. It's almost always better to exhaust out of the building. Of course, there are certain jurisdictions, mainly California, or certain uses where the abatement's required with like a thermal oxidizer, but carbon filtration is never required. That's just customer driven.
Seems to me if they're a foot thick, wouldn't that affect the airflow?
Yeah, no, you can't use a standard fan on carbon filtration. You're going to have something that overcomes this massive amount of static pressure caused by that filtration unit. The cost of a carbon booth is going to be quite a lot more than a standard spray booth as well. How far above the roof do I need to exhaust? This is referring to a liquid spray booth.
6 feet above the highest point.
So close. There's one more sentence on there. It's 6 feet above the highest point of the roof within a 10-foot radius of the exhaust point. So wherever I come up through the roof, I got to go 6 feet above that area within a 10-foot radius.
That keeps it kind of smart because commercial roofs can be tens of thousands of square feet.
Yep, exactly. And you might have a huge pitch.
40 foot, yeah, stack.
Right. Do powder booths need an exhaust? I should actually change that question. Do powder booths need an exhaust to outdoors?
No.
Correct. No, powder has no volatiles and no VOCs. It can be captured and contained with proper filtration. Normally, we will have 2 to 3 stages of filtration on a powder booth to accomplish this. Okay, here's one you guys all need to learn how to do. How do I calculate the CFM required for a spray booth? No guesses?
Is that a question? Depends on the type of spray booth.
Yes, it does. So generically, you're going to take the cross section of the direction the airflow is going and measure the width and height times the average feet per minute required. Let's put that into actual practicality. Okay, so if I have an open face booth or a cross draft booth, I want to take the direction the airflow is traveling, which is forward, right? So I'm going to take the width. So let's just say I have a 10 by 10 open face booth. The width is 10 foot, the height is 10 foot, and I said we need to move 100 feet of air a minute. So 10 by 10 by 100 is going to be 10,000 CFM in that booth. Does that make sense?
So
Yeah.
it's good. Yeah, absolutely. But this is good when sizing the motor. for
Yes.
them?
This is how you figure out the fan, and then the motor will size to the fan because there's always a fan curve, right?
Yeah, exactly. Okay.
Okay, so if this is a downdraft booth, I'm not going to take the width times the height because that's not the direction the airflow is going. I'm going to take the depth, not the width, right? So if my booth is 30 feet deep, I'm going to take 30 feet times 10 feet high times 50. So that'd be 30 times 10 feet high times 50 feet a minute. That'd be 15,000 CFM. Does that make sense?
Yep.
All right. What is static pressure? Static pressure is the amount of resistance generated by air flowing through an object caused by friction of the object. I guess I should say it's, in this case, we're talking about static pressure for air. There's static pressure for fluid. we deal with that in paint hoses and stuff all the time as well. So in this instance, we're talking about the static pressure that the spray booth air is experiencing by having friction by going over any object. It can be on the intake side, it can be on the exhaust side, it can be the filters themselves, all cause static. So an example, a spray booth filter is rated for a 1/2 inch of static pressure. This means that a fully loaded filter will give your booth fan a load or a rating of a 1/2 inch of static pressure. That means if you put a fully loaded filter in, such as versus a new filter, the static pressure is much less and your airflow is higher. So it's essentially saying a new filter, it's going to allow your booth to move a lot more air because there's no load on the fan versus a fully loaded filter.
And is that a 1/2 inch of water column?
Yes.
Okay.
In spray booths, we measure everything in water column pressure. That's how we.
To put it in terms that I'm so used to, that's about the pressure of a propane bottle.
Yeah, it's about 1/4 psi.
Yes.
Maybe less. Okay,
Well,
so
go ahead.
But-
Well, I was just going to say the weight of propane is a little heavier than other
Sure.
gas, so it makes a little bit more of a difference. But you're absolutely right. So would the weight of humid air, like say down in Georgia, be different to measure than it would say in Arizona, Phoenix?
Yeah.
yes, normally on the exhaust side, that isn't so much of a calculation. When you come to air makeup and fan and burner sizing, you do have to know the elevation and the area of the country. There's a calculation for, figuring out your airflow and static pressure on the air makeup side. And that's a lot more dependent upon pressure, humidity, and load over in the elevation.
Sure.
So, which is interesting. I ask you guys always to fill out that RFQ form, and one of them is the customer's, name and address. The address is part of that because that tells us the zip code, so we can pull these fan curves on air makeup systems. So we actually get that from the zip code. There's a system that gives you information for rating your airflow on a air makeup system. So the basic information is actually helpful. All right. If we were required by code to move 100 feet of air per minute, that would still require that with fully loaded filters. So with dirty filters, I still have to move that 100 feet of air a minute. That means with new filters, we're going to be moving more air, probably about 25% more air, right? Because there's no static load on it. So we're going to be moving around 125 feet per minute with a new filter versus a full filter. So there's an example of static pressure. Another example of static pressure on the exhaust side is the ductwork. Your exhaust fan can encounter significant static pressure based upon your design, and that can happen quickly. Normally, every 90-degree turn adds 1/4 inch of static pressure. And remember, we normally buy a regular spray booth fan rated for only a 1/2 inch of static. So all of a sudden, a customer puts a 90-degree duct on a standard fan. What happens? He just cut his static pressure in half with one turn.
What about a 45 degree?
A 45 degree adds an 1/8 inch of static pressure. And even straight duct adds static pressure. So every 10 feet of straight ducting adds these are all abouts, an 1/8 inch of static pressure. Each diameter of duct, the smaller it is, the more that effect, the larger it is, the less this effect, just so you know. But I'm giving you in generality how I kind of calculate static pressure when we're doing this. Now, our spray booth engineers are going to see your path of exhaust, and they're going to compensate by either oversizing the fan or adding calculations for additional static pressure there. But you ever have a customer who wants to just buy a spray booth and I don't want to talk about the exhaust and the duct? Pretty important to have that conversation because he might be planning to put a 90-degree elbow on it, or two or three, and wants to know then why this spray booth doesn't move the exact amount of air that he was told it would. So if we're only set up to move a half inch of static and this guy's put on a half inch with the ductwork, the filters don't have a chance, right? So things we can do to overcome static pressure, and as far as the ductwork design, we can increase the horsepower of a motor. We might switch from a tube axial fan, which is what you normally see on a spray booth, to what's called a vane axial fan, which is, in other words, a squirrel cage fan, and that can overcome higher static pressure. Make sense? Is air makeup required if I put in a spray booth? Anybody know the answer to this?
Maybe.
It's actually a yes. That probably surprises most people. So why is air makeup required on any spray?
Balance the pressure of the building.
Yep. For safety reasons, a building cannot or should not be left under negative pressure. Why not, right? Negative pressure could cause doors to slam, causing injuries to hands or fingers. Negative pressure could affect the in-house HVAC systems, and negative pressure could result in affecting pilot lights of natural gas systems. You could suck the flame out if it's bad enough, right? So regardless of what it is, there is a requirement for air makeup. Now, that doesn't mean what you might think it means. What air makeup is required? You can get air makeup in two kinds, okay? You can get what's called a passive system or a pressurized system, okay? An example of a passive air makeup system can simply be a vent or a barometric or powered louver. We sell those wall shutters all the time like that. So as long as there's a way for the air to get back into the building, as simple as a vent, that counts as air makeup. But if I have everything sealed off tight and nothing can get in, that building will be under negative pressure. That is your problem. So you have to make sure a customer has thought of, especially if they're doing a booth themselves, air has to get back into that building.
Well, it would affect the airflow as well through the booth.
Yeah, it'll cause a lot of static pressure if it's got no new fresh air to come in. It'll give you a
all the paint's going to be floating around in the booth.
Yep, exactly. Okay, so air makeup can be supplied in a passive system or pressurized. A pressurized heated air makeup can come in two forms. It can come in heated and non-heated, okay? Heated air makeups in many air quality districts, especially in California, now require low NOx burners. We talked a little bit about that on ovens. That is the type of burner that requires source testing and third-party testing to make sure that it's burning more of the spent fuel after the initial burn, essentially, and it adds a lot of expense. The burner itself is more expensive, as well as the source testing that's required from a third party. All right, here's an example of a non-heated pressurized air makeup. So that's blowing air in, it's filtered, but there's no burner box. There's nothing that's heating that. Here's an example of a heated air makeup system. So that's taking the fresh air in, going across the burner, and then blowing that air down. Does that make sense?
Mm-hmm.
In hot climates, Jeff,
yes,
cooling systems may be needed. So cooling systems are available typically in two different types. There's evaporative coolers and there's your typical air conditioning units. Cooling air is significantly more expensive than heating air, and that surprises a lot of people, but it is a ton of energy and expense to cool air, especially at the rate and volume that a spray booth is doing it. You're not really allowed to circulate air. It's in and out, right? So it becomes a lot. These are examples of evaporative coolers. I actually installed these in Arizona a few years ago. That essentially has air go across a filter system, and then there's essentially a waterfall system. The air goes through that water, snakes around it, and the act of passing through the water cools the air, and then it goes through, sucked by that fan, and is blown into the building and diffused. So an evaporative cooler is just that. It's essentially a waterfall of continuous, pumped water. The air flows through the water and it cools the air by the act of passing through or by the water. Does that make sense?
Yeah, but is the water, it's not recycled, it's just lost, right?
No, the water is pumped around and around and around. Then it just has a fill. Like it's eventually evaporated, yes.
It has a float. It just keeps a bath of water.
It keeps a bath of water, exactly.
Now, Todd, do we sell that evaporative cooler?
Yes.
Okay. Wow. Okay.
Absolutely. Now, something to keep in mind, if you put an evaporative cooler on, it's going to add humidity into the building because you're evaporating water to cool the air. You're adding humidity as you do that. In Arizona, that's going to be absolutely not a problem. In Georgia, they're not going to like that very much. It's already 95% humidity, right? So you may need to go to an actual, condensed type air conditioning unit there, and that's going to be a lot more money. An evaporative cooler is probably 50 to 80 grand for a typical automotive booth. An air conditioning unit's probably 250 grand for a typical automotive booth with condensers and all that. Now you can control humidity with air conditioning because it's actually going to dry things out, right? So that's how we do humidity controls, is essentially using air conditioning and heated air makeups to control adding or drying air, or evaporative coolers to add humidity.
Yeah, plus operational cost.
Mm-hmm. In aerospace, sometimes we get specific humidity where they want to keep it in a range and it's a dry environment, and they might need to have 50% relative humidity in the booth. We'll actually put an evaporative cooler on to add the humidity. Then it will go through a heated air makeup where the flame will dry out some of the humidity, but we can control how much humidity is going through based upon temperature and how much evap cooler time we give it. So there is controls for humidity, both adding and taking away. Always easier to add humidity, much more expensive to take humidity away.
Do we offer installation also on all this?
We do.
Okay.
Here's another good question. What type of floor should a spray booth be built on?
Concrete.
A spray booth must be set on a non-combustible floor. Never put a spray booth on asphalt, dirt, or wood flooring. I can't tell you how many times I've had a guy say, "Oh, I've got a parking lot, I'm going to put a spray booth up." Not on asphalt, you're not. It's very important for the floor to be level. Ask any spray booth installer, it's the bane of their existence, these crooked concrete floors, because you can't get your panels to line up if the concrete floor you started on isn't level. So non-level floors will cause all kinds of issues. You have to put shims or caulk it or try to build things up with wedges. It's a pain. So make sure your customer has level floors.
Ty, now you said ask questions. So
yes,
what
please.
if a customer does want to put it out in the parking lot, like a sealed spray booth? Do you have them cut the asphalt and pour concrete?
Yes.
Okay. That's a simple thing to do, guys. I mean, being from construction, it's not that hard. Asphalt's only about 2 to 4 inches thick anyway. And
it moves the entire time. So you don't want to have asphalt under a booth anyway. Okay. Is it important that my spray booth be ETL or UL listed as a whole?
Yes.
Correct.
Yeah.
If you've ever noticed, most of our quotes say the spray booth is ETL or UL listed, depending on who makes it, right? So it's very nice to have a spray booth listed as a whole. This prevents an electrical inspector from reviewing anything after the control panel other than the main power in. It also helps avoid creating frivolous charges that can create expenses and consume time. So essentially what I'm saying here is with an ETL listed booth, the inspector can look at where the electrician landed main power to the panel, and then his jurisdiction stops, right? And these inspectors can get very, very frivolous and create all kinds of, I don't like the connectors you used. I didn't like the gauge of wire. I like it in some kind of different conduit. I like a sticker over here. You know, they come up with all kinds of things. I've seen it where they had a customer have to pay for third-party listing because they don't want the liability of inspecting it. And that's a whole new thing that's going on out there now. So having a booth arrive that's completely ETL or UL listed just stops problems.
Do they still have CSA in Canada?
Yes. Yep. So what's the difference between listing a booth as a whole versus listed components? Okay. Most spray booth manufacturers do use UL or ETL listed components. That does not mean that their entire booth is listed as a whole. It simply means the inspectors couldn't check the internal wiring of an individual component. He couldn't open up a light, for instance, and say, I want to know the wiring diagram of this light internal, right? But once you put all those things on a booth, the lights, the fans, the control panel, the door switches, the gas valves, all of that stuff, he would have full reign and access to review it, require anything that he deems fit, and, you know, it'd be at your or your customer's charge. So even though a competitor may have UL listed components, the customer gets no assurance that the inspector can't cause frivolous charges or delays in their time, right? So when a booth is listed as a whole, the entire booth, including the structure, the metal structure, the engineering, the everything of it, the electrical is all considered one working device. And the inspector cannot go past that sticker. He can't ask you any more questions other than, where's the main power go in? Thank you. Make sense?
Sure. Yeah.
Very cool.
What is the area around a spray booth that is considered the hazardous zone?
3 feet from any opening.
Correct. So the NFPA 33 dictates that any area 3 feet from the opening of a spray booth is a class 1 div 1 hazardous rated area. After you've traveled the 3 feet distance from any opening, it is recognized as standard electrical zone that whatever that building is rated for. So if that room's just standard electrical, then after 3 feet, you're back to standard electrical. You get asked a lot because people will want to put an outlet right next to a door. You can't do that because there's a 3-foot bubble around any opening that's still a class 1 div 1 protected zone, right? Or someone will want to move a piece of machinery or another booth right next to this one. They need to be 6 feet apart if you're trying to put two booths that aren't connected as one structure together, because they each would have a 3-foot zone. So 6 feet becomes your buffer between devices that aren't recognized as one booth. If that makes sense.
Things like outlets that are explosion proof, things like that.
You can put class 1 div 1 rated outlets in or around a booth, but normally you couldn't find a device that would hook up to that easily. That's quite the thing. It's usually easier to run class 1 div 1 seal tight to the actual appliance itself. It's not a plug, it's just hardwired in.
Yeah.
An electrician would do that, but anything inside of a booth is a class 1 div 1 environment and 3 feet around any opening. So the motor on top of the booth doesn't have to be explosion proof because it's more than 3 feet from a door, right? The lights around on the top of the booth are general purpose lights because they're not in an explosion proof zone. But if a light was within 3 feet of a door, then it does have to be a class 1 div 2 device.
That is very interesting. The motor doesn't have to be.
It's not in the hazardous zone. It's on the outside. Only the interior and 3 feet from a door or an opening is the hazardous zone. That's why all the lights have the glass and the seal tight, on it. Do all states have the same basic code requirements is what I should have put here.
No.
No, as you mentioned California a few times.
Well, yes and no. Okay. So all states are required to follow the international building codes and the national codes, your national electric codes, your NFPA 33, all of that. What you will find though, there are some states that have slightly more stringent requirements. So they've increased the code requirements from what is a national standard. Okay. So yes, like you said, the low NOx requirement, but I just put down here, since we cover all the country, a couple of strange ones to be aware of. So Texas has a weird one. They require the exhaust stack to be taller than 6 feet above the highest point of the roof. In fact, they require the exhaust to be 1.5 times the entire building height. So if you had a 30-foot building, you would need a 45-foot exhaust stack in Texas. Are you aware of that?
They do everything bigger in Texas.
Of course.
Right?
Bigger and better.
Florida, this is for you, Al. Florida requires the use of tie-down cables on all exhaust stacks due to hurricanes and wind loads.
Makes sense.
Those cables that you see coming off of a stack sometimes, those are always required in Florida. Like we said, California has the low NOx on most of their larger populated areas. Here's Corey's question. Can TFS install booths anywhere? Yes. We have a network of installation contractors in North America. We can install booths anywhere in the USA, Canada, or Mexico. So we do a lot of ducting. So we wanted to give a little attention to ducting design. How does the weather cap keep rainwater out of my exhaust stack?
Doesn't it have like a squirrel cage?
On the weather cap?
Pardon me?
Not on the weather cap. So the upflow cap opens when the spray booth exhaust fan creates positive pressure in the duct. It closes via gravity when the fan is off. So I'm going to show you an example. Okay. So this is right off of our website. You see how those little flaps on the D6 in the center there, those would flow up and open when the exhaust fan is on. When the exhaust fan turns off, gravity is going to cause them just to close.
It's like a bathroom vent on the outside.
Okay. So a proper exhaust duct system consists of the following. So the exhaust fan, that would be FN1. The connecting ring would be the thing that connects the ductwork to the fan. That's just above FN1 on that diagram. The duct with clean out hatch, that's right above the ring. That's D3 and D2 on that diagram. Additional ducting, should you need it, that would be D1. So that would be ducting that doesn't have a clean out door. Transitions aren't shown on this, but if you needed 45s to go over to transition, to make it between rafters or something like that. The roof collar, which is D5, right? And here's something that you all need to be aware of because we get this question all the time. The roof collar must be 6 inches in diameter larger than the duct for fire code, so that if there was a fire in the duct, there's a space for the heat and energy to dissipate that isn't just pounding it right into the roof structure that's next to this collar, right? A lot of times they'll require you to put an insulated sleeve of non-flammable wool in there, but there's a requirement for it to be larger, okay? So we get questions a lot when we sell duct work. Well, hey, why is the weather cap so much bigger than the duct? You sent me the wrong size. No, we didn't. That's the way that it goes. Okay. And then there's flashing, D4, which you can see on that thing. That's what goes around like a skirt, they call it, so that it doesn't flow into the larger diameter roof collar. Does this make sense?
Mm-hmm.
Okay. And then you have the upflow cap, D6. I wanted to go through this because we get so many questions on exhaust duct work. I think we now have a very good diagram on our webpage that shows this. Corey goes through this probably every other day with people online. Do you have any questions on duct work?
Oh, wow. I know on our flashing page, it's 2 inches is all, and I think we need to update that to 3 then.
Yeah, let's get clarification on that, Dallas, if you would. It should be, so it's 6 inches total.
Total.
It says right there.
Just to be clear, from the spray booth to the roof, it's 3 feet.
No, we're
6 feet.
talking. No. What's your question?
No, it's different from what you're talking. So the ducking from the spray booth, from the fan up to the roof, to the bottom of the roof of the building, what is the legal, is that 3 feet or 6 feet?
No, there's no requirement for that whatsoever.
So it could be a foot off, and that's enough as long as they go 6 feet off over the highest point.
Correct. You would need to make sure that the roof of the building is not combustible material, because if it was within 3 feet and it was made out of a combustible material, it would have to be over 3 feet away.
Okay.
Well, is tar considered combustible?
Yes.
Because a lot of those flat roofs are tarred.
But I'm talking the underside of the roof.
Oh, the underside. Gotcha.
Okay. Anybody know what that is?
Weather cap.
Well, that's a really old style, very popular thing called a China hat. A China hat may never be used as a weather cap on a spray booth. It impedes the airflow and it greatly increases the static pressure. In fact, a China cap probably adds a 1/2 inch of static pressure by itself. Okay. If you see a China hat in use, it's a sales opportunity to replace it with a standard spray booth upflow cap. Customers in air quality management districts can be fined for using China hats. So if you see one, ask them if they'd like to replace it. It'll make everything work better. Their booth will have more airflow. They won't be in danger of a fine. The new upflow caps don't leak. This is just very old technology and not legal for a spray booth. Okay, so on our website, we have code questions. There's a link to the NFPA 33 document that has a total finishing, overview to it, so you can walk through what's important to spray booth design and construction and ovens and air makeups. And then there's also a spray booth request form, which I've also emailed to all of the sales reps. And I ask that you would please use that form when doing, any kind of request for quote. All right, I'll stop the screen share.
Where are those links referenced? Is it in the Total Finishing Solutions website.com?
Yes. You go to Total Finishing Solutions and you go under any page that has to do with spray booths. At the bottom, it will say code questions. You click on code questions and there's a download, a PDF about the NFPA 33. In fact, Jad, if you want to take the screen over and just show that real quick.
Does it have the entire NFP 33 or just that?
It has an abbreviated version that shows you what's relevant to 99% of the spray booths that customers online are going to be looking for. So it's a nice thing you can either attach when you submit a spray booth quote, or that you can give a customer who needs help as a reference tool.
That NFPA guide is on supplies as well on every booth page.
Okay.
And everybody got the, oh, I see Dallas shared the
I put that link there a long time ago.
files there. Yeah.
Yeah, saw it.
Okay. So yeah, there's the link for that. Okay. Does anybody have any questions, things we want to review before we wrap this up?
The only thing I note was the pitched roof. Make sure so I just want to make sure you mention that to the guys.
Yes. When you're doing the RFQ, I need to know always if it's a flat roof or a pitched roof. You need to know the distance from the floor to the ceiling of the area where the booth is going to go. You need to know the voltage and phase power. You need to know if we're installing it or not. Are they permitting it? And if so, will they need a permit package prepared by us and our engineers? Take photos anytime you go, take measurements, those laser measurement things that, you hold against the wall and it shoots a laser across and tells you floor to ceiling height or dimensions of a room. Very invaluable for making sales calls for spray booth consultations. Make sketches, make drawings, things will help. All right. Any other questions on spray booths?
We don't have those laser measurers in our stock. Is that correct?
We don't sell them that. We'll just go to Home Depot and buy one.
Okay.
And also make sure, guys, when you're doing booths and planning systems or putting a robot in there, the control cabinet are not explosion proof. Those need to be 3 feet away from any openings. So just when you're doing a system design, make sure and be aware of that as well. That know the dimensions of the control panel and where you're going to put it, so you don't end up in a bind later on.
Exactly. All right, guys. Well, I appreciate everyone's time and attention, and we'll make this a post so that you can go back and rewatch this video. I will probably make that PowerPoint available to you in PDF as well, so you'll have that as a resource going forward.
Nice.
And we'll catch you guys next time. Thank you.
That was awesome. Thank
All
you.
right. Thanks, Matt.